Welcome to our journey into the mysteries and importance of the ozone layer. In this video, we'll explore the invisible shield that protects life on Earth, understanding what it is, why it matters, and how human actions impact its health. From the formation of ozone high above our planet to the efforts taken worldwide to protect it. Let's uncover why the ozone layer is essential and how it affects every living thing on Earth. High above Earth's surface lies a thin, invisible layer of gas that has a powerful influence on the health and sustainability of life below. This is the ozone layer, an essential shield that forms a delicate yet vital boundary. Absorbing harmful ultraviolet, UV, radiation from the sun. The energy from this radiation could be extremely damaging to life on Earth if left unchecked, causing severe consequences for ecosystems, human health, and the natural environment. Yet, thanks to the ozone layer, most of the dangerous UV light is absorbed, allowing life to thrive under its protective cover. The story of ozone starts with oxygen, one of the most abundant and crucial elements in Earth's atmosphere. Oxygen molecules are made up of two oxygen atoms, and under certain conditions, these molecules are broken apart by sunlight, allowing each free oxygen atom to bond with another oxygen molecule. This forms ozone, a molecule made up of three oxygen atoms. The creation and destruction of ozone occur continuously in the stratosphere, about 15 to 35 kilometers above Earth's surface, in what is known as the ozone-oxygen cycle. When UV radiation from the sun strikes an oxygen molecule, it splits into individual atoms. These atoms can then combine with other oxygen molecules to create ozone. While ozone molecules themselves can break down, releasing heat and providing a protective barrier. This continuous cycle of formation and breakdown makes the ozone layer self-sustaining under natural conditions. However, it is sensitive to other chemicals which can disrupt this delicate balance. The existence of the ozone layer has not always been known to humanity, and it was only through scientific exploration in the 20th century that we came to understand its significance. Discoveries by researchers like Gordon Dobson, who created the first device to measure ozone levels in the atmosphere, shed light on the distribution and thickness of the ozone layer across different latitudes and seasons. One of the key roles of the ozone layer is to absorb the sun's UVB radiation, which is particularly harmful to DNA and living organisms. This layer absorbs most of these harmful rays, allowing only a safe amount to reach Earth. Without the ozone layer, exposure to UV radiation would increase drastically, impacting not only humans but all life forms. Excessive UV radiation can lead to skin cancers, cataracts, and other health issues in humans, while also harming plant life, marine ecosystems, and animals. But over time, it was discovered that human-made chemicals could cause significant harm to the ozone layer. In the 1970s, scientists began investigating how compounds such as chlorofluorocarbons, CFCs, were affecting the ozone layer. CFCs, once popular for their stability and non-reactivity, were widely used in air conditioning, refrigeration, and aerosol sprays. However, their stability meant that they could drift into the upper atmosphere without breaking down. When they eventually reached the stratosphere, CFC molecules were broken down by intense UV radiation, releasing chlorine atoms, which then reacted with ozone molecules. A single chlorine atom could destroy thousands of ozone molecules, leading to thinning of the ozone layer. The issue of ozone depletion became even more pressing when scientists observed a large seasonal depletion of ozone, later called the ozone hole, over Antarctica. In 1985, researchers announced that the ozone levels above Antarctica were dropping to extremely low levels each spring, as colder conditions allowed clouds to form in the stratosphere. These clouds provided surfaces for chemical reactions involving CFCs, amplifying ozone depletion. This revelation sparked global concern, as it showed just how fragile and responsive the ozone layer was to human influence. In response to these alarming findings, the international community came together to sign the Montreal Protocol in 1987. This landmark agreement aimed to phase out the production and use of CFCs and other ozone-depleting substances, ODs. The Montreal Protocol remains one of the most successful environmental agreements to date, with nearly every country in the world committing to its goals. By reducing the release of ODs into the atmosphere, the treaty allowed the ozone layer a chance to recover. Studies over the years have shown that ozone depletion has begun to stabilize, and some areas have even seen a partial recovery, highlighting the positive impact of coordinated environmental policy. Understanding the recovery process of the ozone layer has continued to be an important focus for scientists. Recovery is slow because many of the CFCs released in previous decades are still present in the atmosphere due to their long lifespans. Even as new chemicals like hydrofluorocarbons, HFCs, replaced CFCs, scientists had to evaluate whether these alternatives were safe for the ozone layer and climate. While HFCs do not deplete ozone, they are potent greenhouse gases that contribute to global warming. This has led to new policies to phase down HFCs as well, showcasing how the complex interplay of atmospheric science, human technology, and environmental policy continues to evolve. The ozone layer's health remains essential for the entire biosphere. Even a small change in its thickness can affect Earth's ecosystems. In regions with thinner ozone layers, UV radiation can penetrate more deeply, stressing plants and affecting their ability to grow. Marine ecosystems are also vulnerable, as phytoplankton, the foundational organisms in oceanic food webs, are sensitive to UV light. Disruptions at this level can ripple through the entire marine ecosystem, affecting fish populations and, by extension, human communities that rely on these resources. The lessons from ozone layer protection have implications for how we address other environmental challenges, such as climate change. The success of the Montreal Protocol demonstrated that coordinated international efforts could address complex environmental issues. It highlighted the importance of science in understanding environmental threats and underscored the role of policy and global cooperation in implementing solutions. The concept of global stewardship, where nations take collective responsibility for the planet, became more widely recognized as essential for tackling planetary health issues. The future of the ozone layer continues to depend on both policy and scientific research. Monitoring programs by organizations like NASA and the World Meteorological Organization provide valuable data on the ozone layer's health and track changes over time. Satellite technology allows us to observe ozone concentrations across the globe, giving us real-time insight into the recovery of the ozone layer and helping scientists refine models that predict its future. The importance of maintaining these efforts cannot be overstated, as vigilance will ensure that we avoid setbacks in ozone layer recovery. Today, the ozone layer is a symbol of the relationship between human activity and the natural world. It serves as a reminder of how interconnected we are with the environment, how our actions can impact global systems, and how scientific understanding can guide us towards sustainable practices. The story of the ozone layer is one of hope, showing that with knowledge, awareness, and commitment, humanity has the power to protect and preserve essential aspects of the natural world for future generations. Through continued education, research, and collaboration, we can ensure that the protective veil of ozone above us remains intact, safeguarding life on Earth from harmful solar radiation. In the end, the ozone layer's story is a journey from discovery to crisis to recovery, and it reminds us of our capacity to make a positive difference. Just as we've worked to protect the ozone layer, we face new challenges that will require the same dedication and cooperation. Understanding the science behind environmental phenomena like the ozone layer helps us see our role within the Earth's complex systems, emphasizing the importance of actions that respect and preserve the balance of nature.